Let's look at this example on valuing a variance swap. Marco longs a one-year variance swap on the S&P 500 at a strike of 22%. This is quoted as an annual volatility. The Vega notional is $100,000. Now, 2 months have passed and the S&P 500 has experienced a realized volatility of 18%. And realized means that this is historical volatility. On the same day, the fair strike of a new 10-month variance swap on the S&P 500 is 26%. So this is the implied volatility. Alright, now determine the mark-to-market value of the variance swap for Marco, assuming an interest rate of 3% per annum. So what we need to do is first, because you're given the Vega notional, we have to convert it to the variance notional. So to get the variance notional, we will take the Vega notional, divide by 2 times the strike, right? So we need to take the Vega notional, divide by 2 times the strike. So that would be 100,000. Then we would divide by 2 times 22. So be mindful to just use 22, don't use 0.22. And if we calculate this, we would get 100,000 divided by bracket 2 times 22. So that would be 2,272.73. So that would be 2,272.73. All right, now to do the valuation, we will need to determine what is the weighted variance on the valuation date. So if you look at the timeline, they entered into a 1-year contract. Let's say it is 1 year. All right, and now you are at month 2 because 2 months have passed. So the realized volatility, okay, the realized volatility is equals to 18. I'll just put 18 is 18%. And we have the implied vol. So there is the implied volatility, which is 26 or 26%. So we're going to take a weighted average of this. So this is 18% is over 2 months, which is 2 over 12. And that 26% is over 10 months. So what we're going to do is we'll take a weighted average, a weighted variance, I call that. So that's 2 over 12. Okay, 2 months out of 12 months times 18 squared. So it has to be the variance. Okay, we'll plus 10 over 12 times 26 squared. So what does that give us? So we have 2 over 12 times 18 squared plus 10 over 12 times 26 squared. So that gives us 617.33. And finally, we can get to the valuation. So the value, okay, so the value of the variance swap, and this is to the long position. So we will take the variance notional, okay, which is 2,272.73. We multiply by the weighted variance. This is for the long position. We minus the initial strike, 22 power 2. Then we will discount it. So this is the amount at year 1. Okay, so we have to discount it from year 1 to month 2. So I would have to divide by 1 plus 3% for the discount rate. And I'll discount this back by 10 months. So that is 10 over 12. Okay, let's do it one by one. So we have 2272.73 times bracket 617.33 minus 22 square, close bracket, divided by open bracket 1 plus 0.03 times 10 over 12. 10 over 12. So that would be 295,632. Okay, 0.28. So that would be a gain for Marco since he is in a long position. For the short position, it would be a loss. Now, another question that you need to be able to do is, let's say at expiration. Okay, now let's say 1 year later, the swap has expired, and on that very day, we measure the 1 year realized volatility as 30%. Okay, so we will use this to calculate the settlement amount. So the payoff, okay, or the payoff or the settlement amount will be it will be the variance notional. Okay, and we multiply by the variance, but based on the 1 year historical volatility, and then we minus the strike squared. So for the variance notional, earlier we computed it as 2272.73. So now your realized volatility is 30. So we'll take power 2, then we minus 22 square, and what do we get? Right, we have 30 square minus 22 square. Right, and we multiply by 2272.73. So that is 945,455.68. So if the realized volatility is more than 22, it will be a positive payoff for the long position. However, if the realized volatility is less than 22, then the long position would have to pay the difference to the other party.